Alright, time for another DraftPhysics.com, debatephysics.com. Also, and whatever, whatever. The debate goes on and on and on and on and on. But anyway, so Ian Gostling has question for draft physics. Okay, whatever. I mean, he's made a mistake again, with his math, and, I didn't fix it very well in my previous video, but I mean, it's that simple, and so he's just arguing from, poor math. But anyway.
Gary, would you do me the honour of please answering this honest question? This is my drawing, and I'd like you to...
Yeah, you draw two different lines, okay? So you're comparing two things, all right? So when you compared, something going twice the velocity to something going the same velocity, the trick is you draw these two separate experiments. But it's two separate experiments. That makes it really easy to see. So again, this is an argument to something so simple, and he just wants to make it complicated for just no good reason. So it's been drawn over and over and over again, and for whatever reason he's decided to change the scenario. So it's a simple enough thing. I have two objects. One of them you're going to give twice the velocity. So one has one velocity, one has two velocity, same masses. And the simple argument is this is a Galilean thing. Okay, in gravity, gravity's going to control the friction. The friction's going to take the energy. So it's gravity taking the energy, essentially. And what's going to happen is you're going to go a distance with one velocity. And when two velocity, you're going to go they're going to go one velocity at some location on this path. And the trick is you're going to go one velocity here. Okay, so right here is where you're going to be going half the speed, or 1v. So you'll be going 1v here, and this experiment will be exactly the same as this. And this will take 1 unit of time, and this will take 1 unit of time. And as you can see, the 1 unit of time, okay, in this case is going to be 3 units of distance. So as Galileo discovered, it's 1, 3, and if I let it go faster and faster, it would be 5, and then 7. That's how it works. So if I make it a 10 to 1 difference, right? I have a 2 to 1 difference. If I make it a 10 to 1 difference, you have to say, oh, wait a minute, this is going to really be a lot of time going, a lot of difference in the time, 10 times the time. And so what I'm going to end up with, okay, is if I did the 1v here, I get this one little distance. I know that's going to be the last distance, the last 1v. There's a point where the thing I'm going to take off at 10v, but I know there's a point where it's going to be going 1v, and it's going to do this little bit. It's going to do exactly what this is doing. So that point is here, let's say. Okay, so now it's going 1v, all right, and it's going to travel that distance, and it's going to do it in the same time that this took. Okay, 1 unit of time. Well, what do I know from Galileo? Okay, well, before that is 3 units of distance. Okay, and then before that, slowing down. So now it's going 2v here. Okay, and so before that was 5. Okay, 1, 2, 3, 4, 5. All right, now it's going 3v. Okay, and then I have to do 7. And then I have to do 9. So I got 1, 2, 3, 4, 5. Right, then I have to do 11. And then I have to do 13. And then I have to do 15. Let's see now. 1, 2, 3, 4, 5, 6, 7, 8. I'm still not there yet. So these are 18 units of distance. Right? And then, 15. And so I have to do 17 and then 19. Alright, so now I finally have 10 units of time. And I've gone from 10 to 9, 7, 6, 5, 4. I missed one somewhere, right? Oh yeah, this is a next stage up. Sorry. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's what you have to add up. 19 plus 17 plus 15 plus 13 plus 11 plus 9 plus... So it's 100 times 100 units of distance for the 10v. It goes 100, not 10 times as far, 100 times as far. So that's where you made your mistake. So, back to the video.
Answer a yes or a no if you agree with what I'm going to lay out or not, because it's important to the argument.
Yeah, you're right. I don't agree.
So I'm just asking you to follow what I'm saying. Won't take long, and give you do you agree or disagree with what I'm saying?
Disagree.
And don't worry about whether the picture is as you've drawn it or whatever. Try and follow along with what I'm saying, please.
Disagree. No, I don't want to do it your way. It's rational to show two different things in two different drawings. There's no point in putting the same thing on top of another thing. So I just say that to start.
This bucket of water in the rain analogy. If it goes from here to here in 10 seconds, let's say it's got enough time.
So why just say 10 seconds? So it goes from here to here in 10 seconds. Going what velocity? You know, you're not even starting off with an argument that makes any sense.
Time for 10 raindrops to fall in the bucket, which would fill it up to the top. If we now increase the velocity to 10 times the amount, it would now the bucket go from here to here in 1 second.
No, so that's where you did it wrong. So if you decrease the velocity, it's only going to be this little tiny distance that it will travel. So if you decrease the velocity to 1/10 of the velocity, you'll get 1/100th, right? It's a squared function. Your own math says so. 1/100th of the distance. So you're not appreciating that at 10 times the speed, you don't go 10 times the distance. Just as at twice the speed, you go at least twice the speed, but we're saying you go 4 times the distance. That's the quadratic part. So you're not accounting for the quadratic part. The part you say is so important, you're ignoring.
And it would catch, say, 1 raindrop. Alright? Now, because it's going 10 times as fast, the complete distance would be here to here, 10 times as much, 10 segments. So if it's cool.
So it wouldn't be. It would be 100 segments. So you're short 90 segments. It's a lot of segments to be short.
1 drop now.
In 1 second, the thing going 10 times as fast will go 20 of these segments. You know, that's the 19 part. In 1 second.
In going 1 second to here. In another second, in this segment, what did you say it would collect? Is it not fair to say it would collect another drop of rain? Would do that here. And because in each section, I think it's fair to say, do you agree or disagree?
I completely disagree that this has anything to do with the reality. Yes, this does not have anything to do with the reality. The fast object will be zooming through this distance and be making new line, 10 new lines. 10 new lines in the same amount of time. Well, no, in 10 times the time, frankly. 10 times the velocity, it's going to take it 10 times the time to slow down. It's going to be in the gravity a long time. But it's going to go an awful long distance.
It would have enough time to catch just 1 raindrop. When it got to the end, Gary, after 10 seconds, how much rain have we got? We got 10 drops of rain at the end. The bucket will be full. The same as if it was going to...
Yeah, sorry, didn't happen. So it'll be 10 times as much rain it's going to collect, because it's going to be in the gravity 10 times as long. So you just haven't got any of these details correct. Just as when it's going twice as fast, it's in the gravity twice as long. You can sort of understand it has to be twice as long, because when it's going 1v, it's going to be in the gravity just as long as the other 1v. The 1v thing is a line this long. That 1v thing is going to be the end of the 2v's path. And then it's got a whole nother section it did in another unit of time. So it has to be in the gravity more time. It's in the gravity twice as long. Okay, yeah, it goes 4 times the distance, but it's only in the gravity twice as long. And it's only put twice the energy into the ground.
10 times as fast, or 10 times slower, shall we say, going from just here to here in 10 seconds. It's got 10 raindrops in it. It's full up. Speed it up 10 times, goes from here to here, same time, 10 times the distance, but it's now got the same rain as it did here. That's my argument. That seems reasonable to me.
Well, I know it seems reasonable to you, but it's just not. It's stupid. And it's stupid for the obvious reason that you're not drawing it right. So if you would draw it the way I drew it, then you'd understand it. Oh yeah, that's right. I have to go 10V, then I have to go 9V, and then I have to go 8V, and then I have to go 7V, and 6V, and 4V, and 3. I have to go all those different velocities, and each one of those velocities is going to be a longer line than that first one. Each one of them is going to be as long or longer.
Well, what do you say, please?
Poop on you. I don't like you much. See what kind of questions. See if anybody here could figure out how stupid what he just did was. You're obviously right. So this is Stephen Broke. So Stephen Broke couldn't even follow along that if something going twice the velocity goes 4 times the distance, then something going 10 times the velocity has to at least go 4 times the distance. It has to at least 4 times. It's going 10 times the velocity. It can't go just 10 times the distance. It has to go a lot more than that. I imagine he will sidestep answering using his usual distraction techniques because he will sense he is being trapped. So again, trapped by what? Completely illogical mush. I mean, 500-year-old, proven by Galileo to be a certainty about what's going to take place. You can't avoid what's going to take place. You're going to travel a high velocity. You're going to travel a great deal of distance in very little time. That's how it works. So yeah, 10 times the velocity, 100 times the distance. Thank you, Steve, for your opinion. Counts a lot to me. So whatever this is, card picker, slosh effect. I'm still thinking about cars taking flight. So he doesn't really understand that. So I guess you have to cut this and then paste it onto a video. I don't know. People don't even know how to post links. I mean, it's amazing how inept people are. So he doesn't really understand that if you go fast enough, you will escape the curvature of the Earth. So I could drive down a highway, and if I drive down the highway fast enough, I'll escape the curvature of the Earth, and I'll go into space. He doesn't even get that that's exactly what Newton figured out, using a cannonball analogy, that there's a velocity. He could shoot a cannonball and it would go all the way around the Earth and hit him in the back of the head. And then there's a velocity that would miss him because it would fly off into space. Idiots. So this is just about air and catching air. This doesn't really have much to do with the speed. So kind of a waste of time watching Formula One cars, which are really, they're almost half airplanes, So anyway, so that's sort of cheating. Anyway, so that's not that interesting. Alright, so that's enough of a video, I guess. I don't know, he made some comment to Puro about, oh yes, he was doing the redundant, can I get back to his channel from here? Apparently I can, yeah. So he's again wondering why you automatically lose kinetic energy when you have $10, you give somebody else $5, now combined you still have $10, you and him, as long as you keep going the same way. But the problem is that kinetic energy says now you still lost $10 worth of value. Okay, so when it's like you started off with 20 and somehow when you gave the guy next to you 5, it cost you 15, and now you only have 5 and he only has 5, and somewhere you lost the 10. And so he's going to try to make sense out of that, and frankly I don't think he can make sense out of it. But anyway, we'll see. Maybe someday he will. But he's sort of denying the truth that clearly in Physics Girl's video, so if you don't want to be a liar, Ian, you just have to accept some things. Physics Girl actually played clips of a tomato getting exploded by a ping pong ball or something. And she used the word deformation. All right. And she used the word sound and heat and vibration. So she implied that the kinetic energy was lost by making little bits fly into space and things happen. And that's where I made the counter argument that, well, you need momentum to make that stuff happen. You have to use something's momentum to make something else move. Something can't move without using momentum. You can't hit the bowling pin with the bowling ball and the bowling ball keep its momentum. It has to lose it. Whatever momentum the pin flies away with, the bowling ball has to lose it. So you can't keep your momentum and lose half your kinetic energy through moving matter somewhere else, giving it to some other object. If you give the energy to some other object, you can't have the same momentum. Alright, so you're sort of cheating the argument. So just understand that physicist Michael and physicist girl both use the word deformation. They basically said you lost the energy because you dented something or you broke something. They're not using some, well, when I put 1 pound on a scale, it weighs 1 pound, but when I put a second pound on the scale, it weighs 4 pounds. They're not using that argument. Because it's not crazy. But anyway, yeah. It's just so tiresome. But anyway, that's what we're stuck with, is tiresome and such. So I think that's enough for video. So till the next time, we'll see where, it's interesting. So new experiments anyway. So we'll see what the new experiments lead to and such. It's kind of tragic and sad that nobody's doing. I mean, physicist Michael is supposed to do some kind of pendulum experiment, where he duplicates the free momentum experiment. But we haven't seen that, and it's too bad everybody gave up on the pendulum and lever thing. But whatever. I guess I'll have to do these experiments eventually. So till the next time, and such and so forth and whatnot.